We're going to work on questions 1 through 5 of our Test 2 practice test. The first question is solve the following inequality. Negative 3b is less than 9. We're going to write the answer as an inequality using less than, greater than, less than or equal to, or greater than or equal to, and graph the solution set. When you solve an inequality, you want to isolate the variable on one side of the equation. So we have negative 3b. We want to isolate the b. Since negative 3 is multiplied by b, we're going to use division to cancel out that multiplication. We're going to divide by negative 3 on both sides. Now, an important difference between equations and inequalities is that whenever you divide an inequality by a negative, you need to reverse the inequality to keep the inequality true. So this inequality symbol is a less than symbol, and we're going to reverse it to a greater than symbol since we divided by a negative number. So on the left-hand side, the negative 3 multiplication and the negative 3 division cancel each other out, leaving me with b on the left-hand side. We're going to reverse that inequality symbol to become a greater than. And 9 divided by negative 3 is negative 3. So we have isolated the variable onto one side of the inequality, and that leaves us with the statement b is greater than or equal to negative 3. And this is the notation that we want to use for part 1. Our answer is b is greater than negative 3. We also want to graph the solution set on the real number line. So we want to mark the value of negative 3 with an open circle. The open circle indicates that negative 3 is not part of the solution set. Reading our inequality one more time, we have b is greater than negative 3. Negative 3 is not greater than itself, so negative 3 is not included in that solution set. The numbers that are greater than negative 3 are the numbers to the right of negative 3 on the number line. So we're going to shade the right-hand side of the number line. These are all the numbers that are greater than negative 3 and are part of our solution set. The next question says solve, graph, and give the interval notation for the inequality. Our inequality is negative 5x plus 1 is less than negative 9. We want to solve that inequality, so I'll start by rewriting the inequality. Negative 5x plus 1 is less than negative 9. Our goal is to isolate the variable on one side of the equation. So I'll start by subtracting 1 on both sides. This leaves us with negative 5x on the left-hand side, less than negative 9 minus 1, that's negative 10. We'll divide both sides by negative 5. And once again, we're dividing both sides of our inequality by a negative, so we need to reverse our inequality symbol. So simplifying the left-hand side, negative 5 divided by negative 5 is 1, leaving us with 1x on the left. We're reversing that inequality symbol because we divided both sides by a negative. And on the right-hand side, negative 10 divided by negative 5 is a positive 2. So we've solved the inequality. We now want to graph the inequality. So we're going to mark on the number line a 2 with an open circle. The open circle indicates that 2 is not part of the solution set, And we can tell that it's not part of the solution set because of the inequality symbol that we're using. We're using greater than rather than greater than or equal to. Equal to would have a little bar underneath that inequality symbol. So if we were going to include this point of 2, we would draw it with a filled-in circle instead of an open circle. So we've marked 2 with the open circle, and we want to shade the numbers that are greater than 2. The numbers that are greater than 2 are going to be to the right of 2 on the number line. So we would shade all of the numbers to the right of 2. And that's the graph of our inequality. We also want to write the interval notation. This is another way to write the solution set. With interval notation, we write a lower bound and an upper bound for our set. I'll just kind of mark it out here. We write a lower bound, comma, and upper bound. And then we use parentheses or brackets at either end of our bounds. So we're going to use either a parenthesis or a bracket next to the lower bound, or a parenthesis or a bracket next to the upper bound. Now, what I mean by lower bound and upper bound is the lowest number that marks out our number line or is a part of the set, or the upper bound, the largest number that is part of the set. Now, the lower bound and upper bound don't have to be a part of the set, and that is why we have these parentheses or the brackets. The parentheses indicates that the lower bound is not part of the set, and the bracket is that it is. So we're going to match how we've drawn the graph here. Remember, we have the open circle on 2 because 2 is not part of the solution set. So 2 is our lower bound, and it is not part of the set, so we use parentheses next to it. Then we're going to do comma, and we're going to come up with our upper bound. Now, some people might think the 5 is the upper bound because it's on the graph, but what we have to keep in mind is that the number line goes on forever, and there are larger numbers that are greater than 2. And this number line actually goes on forever, and so there is no upper bound. And the way we indicate that is by writing infinity. Infinity is that idea that we can go on forever. Since infinity is not a number, we're going to use parentheses on that infinity. So since it's not a number, it can't be included in the set, and we use that parenthesis there. So this is our interval notation. And drawing the graph helps us understand that interval notation. We have the lower bound of 2. The parentheses means that 2 is not included. The open circle means 2 is not included. And then we write comma infinity, and that shows us all the numbers greater than 2 are included in the set. On this next problem, we're going to graph y is less than or equal to -3. And we're given this grid instead of our number line. So remember earlier we were graphing on a real number line. If we were graphing this y is less than or equal to -3 on a real number line, we would mark -3 with a filled-in circle. And the reason we mark a filled-in circle is because we have the equal to symbol, and so that point is included in the solution set. And then we have less than, y is less than -3, so we would shade to the left. So this is the way that we graph it if we're only graphing one variable, and that's on the real number line. But in this example, we want to graph in two variables, an x and a y. So even though we only see y in this equation, we're graphing it as if we have both x and y. So let me take you through the process that we go through for this kind of problem. We have y is less than or equal to -3. The first thing when you graph an inequality in two variables is that you're going to graph the boundary. And the boundary is y equals -3. So to get the boundary line, you change your inequality symbol to an equal symbol. And you're going to graph this line. This line is a horizontal line. So we want to graph the horizontal line y equals -3. But before we graph that line, I want to consider what that inequality symbol is. And if that inequality symbol is a less than or a greater than, we draw it using a dashed line. And that tells us that the boundary is not included. Now for this example, we have less than or equal to, and with that equal to, the boundary line is included in the solution set. So we're going to graph our line with a solid line to indicate that it's included. So we use solid anytime we have less than or equal to or greater than or equal to. So this is a horizontal line right here at y equals -3. So that's our boundary line, y equals -3. Now the second step is you're going to do some shading. Now for the shading, you're going to choose a test point. And there's only one rule with the test point, and that rule is that your test point cannot be on the line. So you can pick any ordered pair on this grid as long as it is not on this line that we've just drawn. So I can pick any ordered pair down here, and I can pick any ordered pair up here. Most people like to pick the point 0, 0 because the math works out really nicely. So here is the test point that I'm going to choose, which is 0, 0. We're going to substitute that test point into the inequality y is less than or equal to -3. When I substitute, 0 goes in for y, and I get the statement 0 is less than or equal to -3. That statement is false. So when that statement comes out false, that tells me that this whole side is false, and the other side is true. And you always want to shade the true side. So we're going to shade below the line because that's the true side. So this is the graph for this inequality, y is less than or equal to -3. Every ordered pair in this shaded region and every ordered pair on this boundary line will make this inequality true. On this example, we want to graph y is greater than x minus 1. This is an inequality because it's a greater than in two variables, x and y. We're going to graph our solution set on our coordinate plane. When you solve inequalities in two variables, We're going to solve them in 2 steps. We're trying to graph the inequality y is greater than x minus 1. And we start by first drawing the boundary. And the boundary will be y equals x minus 1. What I've done is replace the inequality symbol with an equal symbol to create the boundary line. Now, when we draw the boundary line, you're either going to draw it as a solid line or as a dashed line, and the inequality symbol will tell you which one. When we have a greater than or a less than inequality, we're going to use a dashed line. And that's because the boundary line will not be a part of the solution set in that case. So the dashed line indicates that that boundary line is not part of the solution set. Whenever we have a greater than or equal to, or a less than or equal to symbol, the equal to part indicates that the boundary line is part of the solution set. And in that case, you would use a solid line. So for this example, because we have a greater than, we're going to graph a dashed line. So our boundary line is y equals x minus 1. We want to graph that line. There are many ways to go about graphing the line, but this one is written in y equals mx plus b form. That's slope-intercept form. So I know that this line has a slope of 1 and a y-intercept of negative 1. So to graph this line, I can plot the y-intercept at 0, negative 1, use the slope to get to the next point. The slope is 1, which is 1 over 1. So I'm going to rise 1 and run 1. So now I have 2 points on the line. And remember, I'm drawing this line as dashed, and the boundary line is not included in that solution set. So we're going to draw this line as a dashed line, indicating the boundary is not part of the solution. Now the second part of this process is the shading. We have to figure out which side of the line we're going to shade. These points that are below the line or these points that are above the line. The way we decide is by choosing a test point. And most people like to choose 0, 0 as the test point, but you can choose any ordered pair as long as your ordered pair doesn't fall on the boundary line. So our test point is 0, 0. And we're going to substitute that into the original inequality y is greater than x minus 1. We have 0 is greater than 0 minus 1. 0 minus 1 simplifies to negative 1. And we have the statement 0 is greater than negative 1. That statement is true. And that tells me that this side that has the test point is the true side, and the other side is the false side. We always want to shade the true side. So we're going to shade above that boundary line. All of the ordered pairs in the shaded region are solutions to the inequality y is greater than x minus 1. All of the ordered pairs on the boundary line and on the other side of the line are not solutions to this inequality. On this question, we want to express the set negative 8 is less than or equal to x is less than or equal to negative 6 using interval notation. Let's recall what interval notation is for a second. Interval notation is where we write a lower bound, comma, an upper bound, and then we use parentheses or brackets to indicate whether the lower bound is included or not included in the set, and parentheses or brackets depending on whether the upper bound is included or not included in the set. So what I'd like to do on this example is to first draw the number line and graph this set using the number line. That's very helpful in writing the interval notation. So I'm going to draw the number line, and we're going to mark -8 on the number line and -6 on the number line. -6 is less than, -8 is less than -6, so that's why I wrote -8 to the left of -6. I'm going to mark both of these on the number line with filled in circles. And a filled in circle indicates that that is part of the set. And I know that these numbers are part of the set because I have an equal to next to that number and an equal to next to that number. So we can read this inequality as x is in between these two numbers. So I'm going to shade the portion of the number line between those two numbers. So this is a picture of our solution set, all of the numbers between -8 and -6, including -8 and -6. Now, using interval notation, I need to figure out the lower bound and the upper bound. And what I mean by that is the lower bound of this shaded region and the upper bound of this shaded region. So the lowest number shaded is -8. That's our lower bound. The highest number shaded is -6. That's our upper bound. And remember, we're going to use parentheses if the lower bound is not included and brackets if it is. So since we have our filled in circle and our equal to, we're going to include that lower bound. The parentheses or the brackets. Parentheses is not included, brackets are included. Filled in circle is included, the equal to is included, so we want to use the bracket on the upper bound. So we have our interval notation as -8 to -6, including those endpoints of -8 and -6. Thank you for checking out my videos. Have a great day.